We said this section is a study of thermodynamics, or this chapter is a study of thermodynamics, and we said thermodynamics is just a study of heat flow in and out of systems. Basically, thermodynamics also is a study of conversions, interconversions of heat and other kinds of energy. So throughout this chapter, we're going to be looking at interconversions, more specifically of chemical energy to heat energy, and how that happens, and it happens quite frequently. Energy is said to be what is called a state system. What that means is that the system changes. It only matters what the initial and final conditions are. It really doesn't matter how you get there. For example, if I'm traveling to Hagerstown, and I will go there, and I go down 81, and I travel there, and I look at the distance I travel. If I then go down Route 11 the same way to Hagerstown at the same point, the distances might be not the same. That is an example of something that is not a state system. Right? It doesn't matter how I get there. The overall thing is the change in distance. I don't care how I got there. The distances are not the same. Right? So the measurement from beginning to end is all that matters. If I got lost and went off the road all over the place, the only thing that matters is how long did it take me to get there. Now, in thermodynamics is a state system, so it doesn't matter what happens in between. It only happens in the beginning and the final conditions. Now, the first law of thermodynamics is what governs this. The first law of thermodynamics is very similar to what we learned in the law of conservation of mass, in that it states that energy can be neither created nor destroyed. Right? So energy lost by the system is gained by the surroundings. Energy lost by the surroundings must be gained by the system. That's what the first law of thermodynamics says. Now, when we're calculating energy, delta E, there are two variables that play into effect in energy. Q, which is the representation of heat, and W, which is work. The change in energy in a system is the sum of the heat plus the work energy. Now, signs are very important, and conventional signs for this equation tell us that when heat is lost by the system to the surroundings, that is an exothermic process, and we talked about that in the last section. Therefore, we need to put a negative sign in front of the Q. So if the problem says the heat energy is lost to the surroundings or absorbed by the surroundings from the system, then you put a negative sign. If it says the system absorbs heat from the surroundings, then that means it's endothermic because heat is coming into the system. Like putting a pot of water on a stove and turning it on. That is endothermic. You're adding heat energy to the water. Now, the same thing is true for work. Work done by the system on the surroundings, you need to put a negative sign in front. Work done on the system by the surroundings needs to put a positive sign in front. All right, so let's look at an example of how we would use this to calculate total energy change in a system. A gas expands and does work on the surroundings equal to 279 joules. At the same time, it absorbs 216 joules of heat from the surroundings. What is the change in energy in the system? All right, so change in energy, again, which is a state system, only depends on what the overall change is. And we have Q plus W. In this problem, the Q is the heat energy, and it says that it absorbs 216 joules of heat from the surroundings. If it is absorbing heat, that means it is an endothermic process. Energy from the surroundings is going into the system, so it's endothermic. So we know that it is a positive sign. So we have positive 216 joules of energy. Now the work is being done on the surroundings. So it's going from the system out to the surroundings. That is a negative sign. So instead of saying positive or plus, we're going to change that to a negative 279 joules. So 216 minus 279 gives us a total of negative 63 joules of energy. All right, so again, energy is more than just heat. We focus on heat in chemistry, and we'll talk about that in the upcoming section, but work and heat both play a role in the change in energy. Remember your signs. If energy is being lost, then it's a negative sign. If energy is being gained by the system, then it's a positive sign, whether it's work being done on the system or heat being absorbed into the system.